Hello students, welcome to my channel CGAT Maths, CGAT Maths. Myself Dr. Suresh Brother. In this video, we are going to discuss the various possible solutions of one-dimensional heat equation by the method of separation of variables. Students, we have already discussed the various possible solutions of one-dimensional wave equation by using same method already. If you not seen the video, you just go through the description. I will given the link in the description. Understand the various possible solutions of wave equation. Now this is also very easy one. So we are using separation of variable method. Fine. Now by using the method of separation of variables, we are going to substitute u is equal to xt, where capital X is the function of small x and capital T is the function of small t, is the solution by using separation of variables. So let us substitute u is equal to xt in the given equation and observe what will happen. Dou by or dou of xt divided by dou t is equal to c square into dou square of xt divided by dou x square. Look at dou of xt. So left side is the independent variable is small t. So capital X is treated as a constant. You can take it outside. If I take x outside, it will become a just ordinary derivative, that is dt by d small t. Similarly, c square times of, here you can take capital T outside, it will become d square capital X divided by d small x. Next, divide both sides by c square xt on both sides. What will get by dividing? So x already there, x into dt by dt is equal to c square t into d square x by d small x square. You can divide by c square xt. So what will happen? Here x and x get cancelled. Here c square t get cancelled. So remaining one is 1 by c square t into dt by d small t is equal to 1 by x into d square x by d small x square. So by dividing both sides by c square xt, what will happen is the variables are separated. Just look at left side is the function of t, right side is the function of x only. Okay. Look at here. You can assign or equate both sides to common constant k. So on equating both sides to common constant k, 1 by c square t into dt by d small t is equal to small k, and 1 by x into d square x by d small x square is equal to. So I will write in the reverse order. Just look at, and I cross multiply d square x by d small x square equal to small k into x, and here dt divided by d small t is equal to a c square capital T. Fine. Further, this can be written as, okay, I will write this is d square x minus kx equal to 0. Here where d square refers to d square by d small x square. Similarly, the second one, this will become dt minus k c square t equal to 0. Here d refers d by dt. Fine. Further, this is d square minus k into x equal to 0, and this is d minus k c square into t is equal to 0. Call it as equation number 1. Further, you have two cases. What are the two cases? Just look at this. Fine. So I'll rewrite this equation once again. I'll rewrite this equation once again in the next slide. D square minus k into x equal to 0, and d minus k c square into t equal to 0. Just check once again. D square minus k, d square minus kc square, d minus kc square. Okay. So we have various possible solutions. So we need to take k value is 0, positive and negative. So in the case 1, let me go for case 1. Let us take, let k equal to 0. So then the first equation, as you know, this is equation number 1. First equation becomes d square x equal to 0 and dt equal to 0. Further, what are the auxiliary equations here? M square equal to 0. Here m equal to 0. M square equal to 0 means 0 and 0 are the roots. Again here m is equal to 0. If roots are 0, then how do you write the complementary function? Here capital X is the dependent variable. For the two roots with respect to x is the independent variable, we are writing c1 plus c2x into e raised to 0 into x. Here capital T is equal to c1 into e raised to 0 into t with respect to one root. Therefore, by using method of separation of variables, u is equal to xt is the solution. So x is c1 plus c2 x into, this is, we can call it as c3, or this is also same as c1 c3 plus c2 c3 x. or simply which is a plus bx. A plus bx is the solution when k is equal to 0. Fine. Now let us go for case number 2. Let us take k is equal to p. If I take k is equal to p, then equation number 1 becomes d square minus p, so k is equal to p square. D square minus p square into x is equal to 0, and d minus p square c square into t is equal to 0. So what are the auxiliary equations? Auxiliary equations are m square minus p square equal to 0, m minus p square c square equal to 0. Roots are roots are roots are m square equal to p square, or m is equal to plus or minus p. Here you will get m is equal to p square. With respect to plus or minus p, what is the complementary function? Capital X is equal to c1 e raised to px plus c2 e raised to minus px. Since we have already used c1 and c2, I will write c1 dash and c2 dash. Similarly, for the second one, capital T is equal to c3 dash into e raised to t square c square t. Therefore, by using method of separation of variables, u is equal to xt is the solution. c1 dash e raised to px plus c2 dash into e raised to minus px into c3 dash into e raised to p square c square t is the solution. Now we'll go for case number 3. Let us take k is equal to minus p square. Then equation number 2 becomes p square plus p square into x equal to 0, and d plus p square c square into t equal to 0. So what are the auxiliary equations? Auxiliary equations are m square plus p square equal to 0, m plus p square c square equal to 0. Roots are m is equal to plus or minus pi, and m is equal to minus p square c square. Now, what is the complementary function? Complementary function capital X is equal to, when the roots are complex, we are writing c1, and which is purely imaginary, c1 cos px plus c2 sin px. This is I am writing double dash because I am already used this. Similarly, this is capital T is equal to c3 double dash into e raised to minus p square p square. Therefore, by using method of separation of variables, u is equal to xt is the solution. c1 double dash cos px plus c2 double dash into sin px into C3 double dash into e raised to minus p square c square. These are the various possible solutions of one-dimensional heat equation. Thank you so much for watching. We'll meet in the next video.